Projectile motion is a form of motion in which an object or particle, called a projectile, is thrown near Earth's surface, and it moves along a curved path under the action of gravity only. A common misconception with projectile motion is that if you throw an object hard enough, it will travel on a straight path.
However, if you try to throw a ball on a straight path, it will actually move in a curved path towards the ground. This is because although the horizontal component of velocity will stay the same throughout, the vertical velocity will increase. This is because of the force of gravity acting on it, causing it to move towards the ground.
Another important thing to remember about projectile motion is that the horizontal and vertical motions are independent of one another. In other words, no matter how hard that you throw the ball horizontally, it will always accelerate towards the ground due to gravity.
To help you to get a better understanding of this concept, let's go outside for a demonstration. So we're here in my backyard about to do the experiment. Kathleen is going to throw an egg at our fence over there. So we measured that from Kathleen's feet where she's standing all the way over to the fence is about 25 feet, which converts to 7.6 meters. And then we measured from where Kathleen is holding the egg right now to the ground, which is 4.8 feet, which converts over to 1.46 meters. And then we came over here and we marked that exact height on the fence. So our experiment is Kathleen's going to try to throw the egg as hard as she can and as straight as she can and try to make that mark and see if it actually hits that. Okay, so Kathleen is going to try to throw this egg as straight and as hard as she can to hit that mark on the fence. And so I'm going to go stand over here. There's our mark right there, and let's see what she can do. Ready, set, go. Oh. Alright, so here's the damage. We see that it was hit right here, and it kind of like drooped down to the ground, but it did hit that point initially where those, where Kathleen's pointing, and our mark is all the way up there. Okay, so in conclusion, it shows that no matter how hard you try to throw the egg horizontally, to make it hit a point straight across from you, gravity will always take it down.
So just to go over what we did in the experiment, I threw the egg directly straight, so there was no initial vertical velocity, there was only an initial horizontal velocity. Once the egg left my hand, it began accelerating downward with an acceleration of negative 9.8 meters per second squared, which is the acceleration due to gravity, and that increases the vertical velocity. Now, in order to throw the egg at that point on the fence, one would need to throw the egg at an upward angle. So after it reaches its highest point, it would begin to fall back down and hit that point on the fence. So in order to calculate, let's go over the numerical values that we already know. We know that the range, the horizontal distance, which is the range, is 7.63 meters. And we know that the height that the egg was initially thrown at is 1.46 meters. And we will compare the displacement that we calculate to this to see how far the egg fell from the initial position. Then we know that the acceleration due to gravity is 9.8 meters per second squared. And by looking back at the video that we took of me throwing the egg, we saw that the time was 0.5 seconds.
Okay, so you want to start every projectile problem by dividing the paper into vertical and horizontal motion. So we know that since Kathleen threw the egg horizontally, the initial vertical velocity is 0 meters per second, and we're trying to find the final velocity. And we know that the acceleration is negative 9.8 meters per second squared, and the time is 0.5 seconds. So we're going to use the kinematic equation, Vf equals Vi plus At, and the initial velocity is 0, and so then we just have negative 9.8 meters per second squared times 0.5 seconds, which gives you a final velocity of negative 4.9 meters per second. Okay, so now we know that the final velocity is negative 4.9 meters per second, and the time is still 0.5 seconds. So now we're going to try to find the displacement, and we're going to use the kinematic equation d equals Vit plus 1/2 At squared. And the whole first term, Vit, goes to 0 because our initial velocity is 0 meters per second. So you're left with 1/2 times negative 9.8 meters per second squared times 0.5 seconds squared, which gives you the displacement of negative 1.22 meters. Okay, so now we're going to find the horizontal velocity with which Kathleen threw the egg. So we know that the distance is 7.63 meters, and the time that it took is 0.5 seconds, which is the same as in the vertical, since the time remains the same for the entire situation. We also know that horizontal velocity stays constant, so you can use the equation v equals d over t, and that leads you to plug in 7.63 meters for displacement and 0.5 seconds for time, which gives you 15.26 meters per second.
So to conclude, we found that the vertical displacement of the egg was negative 1.22 meters. This basically means that from the starting point that the egg was thrown, which is 1.46 meters, the egg fell to a height of 0.24 meters above the ground. It was also found that the final horizontal velocity was 15.26 meters per second, and the final vertical velocity was negative 4.9 meters per second.
Okay, so to conclude, a projectile cannot take a completely straight path, no matter how fast you throw it with a horizontal velocity, since the force due to gravity always causes the object to take a curved path and accelerate towards the ground.